Okay, I want to actually teach you something about experimental designs and how to do them and what the main issues are, and then give you a little exercise to do, which is to produce an experimental design to a specific little spec. Okay? So there's nothing magical about experimental designs. They actually are just a way of describing how you're going to treat the users and all the things that surrounds that treatment. The word treatment, by the way, is historical because it originates from statistics and originates from clinical work. So the whole of statistics as we understand it today comes from experimental design, comes from medicine or medical science, with a good mixture of agricultural science, mostly on carrots and potatoes, and how to grow effectively things in plots. You find that terminology often comes in. This is what you see in front of you is the sort of most generic structure for a scientific report. Okay? And this is the format I use in your assignments. This is more or less the format of your honors dissertation. Okay? It's always, these documents have always got an introduction and something about background. You then talk about what it is that you did, what you found out, what you concluded, you discuss it, and then you got other stuff. Okay? And that's always the same. In other words, it's a story with a beginning, middle, and an end. And the key issues that you need to be aware of are to do with the users, and they are to do with how to design the study in terms of variables and these treatments. Treatment is a condition for comparison or what you measure. So I want to throw this at you today and to show you something about a problem known as the round-head, square-head problem, which if you learn nothing else, then being aware of that is a big step forward. What you need to be aware of with your users is that there is a major issue in all experimental work involving people, which is based around sampling theory. Whatever you do, you will have a population. And you will, except in the exceptional circumstances, you will be taking a sample from that defined population. Now, when would you have a complete population? Can I ask you people at the back there to stop talking? Please. Thank you. For example, if you'd been asked to do some work on user interfaces for astronauts, then the original astronaut program had what would they call the first 7, right? That's your entire population. That was the world's total population of astronauts. So that's a population, okay? Does that occur in real life? It does occasionally. We find it, for example, in oil and gas and engineering, is that, I've worked with groups of, there are only 30 engineers of this kind working in the North Sea, okay? Okay, so can we have all of them? Yeah. And you've got a population. Otherwise, I'm afraid we're all stuck with the usual, what's your population? Users of Microsoft Word. Oops. That's a pretty big group, okay? So you refine it further. Anybody who writes and who's in education across the world. Come on. So you often have to actually start defining your population and then taking a sample from it. When it comes to consumer products, there is often the marketing people have done background work, approximately at whom the product is aimed. So if you're doing mobile phone work, there is, let's say, a messaging system, and you know approximately what they want to aim it at, a certain age group of a certain kind, but it's still an absolutely huge population that you need to take samples from. So taking samples, sometimes it's done through user panels. It's become a business. British Telecom do a nice business in providing samples for various surveys and so on. And I've put down here undergraduates in psychology because there was in America, if you do a degree in psychology, you actually, as part of your course credits in the first year, you take part in experiments. So the question was asked, you know, these are experiments, let's say, on perception and memory. How typical are these samples? You know, do they apply to the whole of the population, which would be all people over a certain age? So some studies were done, and they showed, yes, they do. Okay, so you can actually restrict your population for research purposes and for, you know, analysis purposes, and still actually you are, your sample is still generalizable to the main population. Okay, but it's something you need to be aware of. Now, what you need to do, and this would apply to any work that you do, particularly, for example, in your dissertations, is that you need to describe the representativeness of your sample. Honesty is the only policy. So given that if you did some work and you want to test it with a bunch of users, you're not going to have enough time to do proper sampling. So you just need to be honest about describing the, let's say, 10, 15 people that you've actually managed to get. They're actually your friends from the class, from a class, etc., etc. Fair enough, as long as you just describe them in detail. The numbers should always be plus 30. That's for statistical representation. Human data becomes normal after 30, okay, when it's measured in a certain way. So you always have a sample of n equals 30 plus. You won't actually have that, let's say, in your dissertations, so you just honestly say, I wish I had. Well, I don't. Well, here's the best I can do. And we accept that. But you need to describe their characteristics. How did you choose them? Well, if they're your mates in a class, we would call it opportunistic example. There's an opportunity for them to take part. You're not doing random sampling or anything like that, okay? You need to describe their characteristics, age, gender ratios, previous experience, background, etc., etc., etc. Whatever it is, my advice to you is collect as much information about your users as you possibly can. You don't have to use it all, right? But it can be very useful to be able to know something about them. Okay. Main focus today is on design. Okay. Like I said, treatment of users has a historical origin in clinical work. Okay. And so design really refers to how you treat your users. There are two major ways you can do this. One is called between users, and the other one is called within users or repeated measures. What happens here is that between users is that you have a sample of users, you randomly allocate a number of n number to a bunch of treatments, A or B. So you can easily think about this as interface A or interface B. Okay? So you have, let's say, 60 people, and you allocate 30 to group A, 30, the other 30 to group B, make them do stuff, and then compare their performances in order to answer the question, is there a difference between A and B? Okay? Very straightforward. Within users means that all your users do both A and B. And then you compare their performance on A with their performance on B. Okay? Now, this is where I want to just tell you about a few other designs and then make a very strong point to you. You'll find that most grown-up designs, which will probably include yours as well, end up as being what I call mixed designs. they are both between and within, because while you can allocate users to a group, users often allocate themselves to a group, which is very important. So, for example, gender, age, experience, and so on is what's called an organismic variable. There's something about the person that means that they actually go into a group. So, for example, if you're old, you cannot also be young. Okay? Or if you're experienced, you can also not be inexperienced, and so on. So there's something about the user that puts them into one group or another. And in a world where we know, for example, that age does affect HCI, and we know that experience affects it in a big way, this is the kind of data that you need to look at, and you might want to compare them. People are slightly differently. Okay? And therefore, you actually divide them, let's say, on the basis of their experience, but at the same time, they all do A and they all do B. Then there are other designs you might come across, matched users. These actually originated, matched users, in identical twin studies. The idea being that identical twins are biologically identical, therefore let's compare them and we keep the biological variable completely stable. But let me ask you a very simple pragmatic question. How many identical twins do you know? And user interface shown at the top as a sample, which can be used for those kinds of designs when needed. And, you know, so it's an important area in its own right. Now, this is the simplest experimental design possible. You have a sample shown at the top as a sample. You have treatment group A and treatment group B to the danger. Relatively simple probability theory. You can show that it's possible to put all the round heads into group A and all the round square heads into group B. Now, there are also possibilities of putting most of the round heads in one and most of the square heads in the other, and so on. But you can see the principle here. The principle is, if you then compare group A with group B, and there's a difference observed, what caused that difference? Was it your interface? Is it that interface A is better than B? Or is it just that the round heads are different from the square heads? Well, you can't know. Okay? In other words, your experiment is giving false results. Bad news. Okay? So, let me illustrate to you. If you used, on the other hand, a within groups design or repeated measures design, then you might look something like this. The round heads take 1,000 milliseconds to perform something in group A or interface A, and they take 120 milliseconds on average in group B, which means the difference between them is 20 milliseconds. The square heads are as slow as anything, okay? They are the people with hangovers, okay? And it takes them a second on average to work, square heads, and then in treatment B, it takes them 1,020. But subtract one from the other, and you get the same number as you do with the round heads. Because they're compared with themselves, the fact that they're overall slower doesn't really matter. It's the difference between the two. That's what matters. In the between groups design, if you had compared them, you would find a 900 millisecond difference. And that is huge, and that is false. So it needn't actually go completely against what you're trying to show, but it's just not true. Okay? So the lesson here is that comparing people with themselves is the most powerful method that you can use, okay? And you always use it unless there's a good reason for not using it. There are sometimes good reasons. For example, in drug trials, you cannot actually have people who are well and healthy and also not well, okay? So you can't compare people with themselves. So in other words, you cannot have people with cancer and people who are then also not with cancer, you know. So you're forced to use. But in more sort of ordinary circumstances, you talk about that treatment A is not independent.
Короче, сравнивать юзеров надо с самих собой, а не какие-то определенные группы.
Independent of treatment B, learn a lot about how to do the second one. The computer day measures one unless something stops you from using it. Now, this is something I want you to do today, which is to produce factorial diagrams. This is what this is called, by the way, a factorial diagram. And this shows you the components of an experiment. There are two experiments here, and these are called mixed designs, because in the one on the left, you've got two groups, group A, group B, and then these are split into two, D1, D2, D1, D2, and that's within users. So in other words, we've taken a bunch of people, call them 60 people, we've randomly allocated 30 into group A, 30 into group B, okay, and we then, everybody does the, let's say, task 1 and task 2. Now, what would make us put them into different groups? Well, I said randomly allocate. What would be most likely is that they could be young and old. So group A is young people, group B is old people, okay? Or it could be experienced, inexperienced, because we think that is important. So this is the one on the right is the common usage. You've got a classification variable, and the users place themselves in a group. So if you're between a certain age, you go into that group. If you're in a certain age, you go into that group. Putting them up, now, both of these examples have two factors, one between and one within. Okay? Now, these things that you're doing, these are the independent variables. These are controlled by the experimenter, you, and basically you are looking at what would be traditionally called a treatment, okay? And there can be more than one, and you then talk about levels of treatment. So, very simple example here. This is a within users factorial diagram, you see, and variable 1 is style of dialogue. There's dialogue A and there's dialogue B. That's why it has two levels, okay? Because of course you've got dependent variables, and they depend on the independent variable. And if you think, then if you're going to compare young and old, okay, then you'd expect there to be some dependency, i.e. they perform something, do something differently, and that is that age depends on, okay, or performance depends on age. So dependent variables are what you measure, and I've given two top-down examples here. Performance, which could then be measured as a reaction time, or attitude, okay? And attitude, of course, is UX. So you've got usability, performance, attitude, UX. Then you define that in more detail as being reaction times, okay, scale. That's the confounding. It is no longer confounding variable. Performance, attitude, subjective measures from people. Now, there's something called a confounding variable, okay? And they are very bad news. But if you have a variable that you know is confounding, it is no longer confounding. It's just a pain in the bum, and you can fix it, okay? Because they've got to be unknown, okay? Unknown parts of your study. They actually come from two sources. One is the environment, and the other one is the users themselves. So, for example, if you were evaluating some people in a noisy environment as opposed to some in a quiet environment, that would have an effect, okay? So some of your people might become squareheads. There's the famous example of the rats and the experimenter. This was an animal learning experiment which strangely went a bit strange, and it turned out to be a perfume called musk, which is a pheromone to rats, so they changed their behavior. Nobody had realized that that would actually happen. Okay? Or you could be treating your users differently. If you've got two evaluators, users could be reacting differently to them. Okay? You kind of the
Ну, с этим понятно, тут все попроще. Короче, где-то так. С этим понятно. Что насчет вот это factorial дизайн получается? Ну, получается, для этого factorial дизайна нужно где-то есть. Понял. То есть independent variables. Task, user interface и прочее. Factorial design. Делаем так. Да, нужны индивидуальные, ну, эти идентичные conditions, когда люди сдают. То есть можно сравнить это с этим, это с этим, с этим, это с этим и так далее. Ага. Ну да, понял. Сейчас долгий будет.
Okay. After having hit you with a dose last week of experimental design, I now want to actually add one to that, which is about measurement, in particular, measurement relating to descriptive statistics and variance. Okay? Now, we're not going to go into great detail with statistics. The key is that you understand in the way that I hope that you understood the square head, round head problem as a major issue, in the same way that I hope you now got a grasp of what a factorial design looks like, so that you can actually design a study properly with independent variables, dependent variables, and watching out for confounding ones. In the same way, I want to repeat a little bit of material here about scaling and so on, but at the same time link it to what you actually are doing when you describe data, because describing the data and understanding what it is that you're doing is absolutely vital. The details of doing stats can always be picked up as you actually go along. So when you plan an evaluation, and this again is a reminder, is that you state a question, pose a problem, you state hypotheses. This is absolutely identical to the process that you've been through with your honours dissertations. You know, you're doing something because there's a challenge, something that needs to be answered or you'd like to answer or explore, okay? And then you plan your study. What guides us in planning studies is what do you want to find out, okay? And you might find that that is sort of almost like horribly common sense, okay? And you think, so that is so common sense that, you know, it's hardly worth mentioning. Trust me when I say that a number of people do evaluation studies without having asked that question. They just have a set of ways of doing things, or maybe some observations, maybe a questionnaire, and they're not doing it for any particular purpose. And they literally, when questioned, will tell you, well, I collected this data and I'm not even sure why. Okay? So it always starts with, there's something you need to find out. Did something work? Does it not work? Okay? And this, of course, is particularly summative evaluations. And so it's basically a piece of curiosity. You don't need formal hypotheses or anything like that to actually just be curious as to, does my new interface work? Okay, have I done something that makes a difference? Okay, can I actually show that something works or doesn't work? And then what you must do is that you design your study based on independent variables, which are the conditions or treatments. These are expressed as a diagram of factors, and again we'll go back to that in the lab today. And what guides you there is you're making a comparison. Okay? Now, I assume that most of you, it takes the piss out of a lot of research. So the question is, if you want to say, is my interface better, then think about it. Better than what? Better than something you've done before? Better than something somebody else has done? Or better than something that's been published? You know, if you find a paper that says on average it takes people this long to access a piece of information, and you can show that you can access it in a shorter period of time, well, that's your comparison. So in a sense, you're always comparing things. You're then doing measurements, that's how you're used to it, to make reliable observations that help. Now, the central principle of doing evaluation is that you want to make reliable observations that help us decide. That's what guides us. Now, what underlies that is that it doesn't matter whether your score or what you measure is qualitative, quantitative, this nature, that nature, as long as it measures what it is that you're trying to measure and gives you the answer. Now, the issue here is that you should never start an evaluation process with, I must be using these measures. I must be doing it this way, okay? Because then you are not, or compare it to designing a user interface where instead of saying, what should it do and what should it look like, you start with the idea, how can I implement it in Windows, okay? Which is considered to be very poor practice. And it's not that it's about Windows, it's about any windowing system. You don't start with the technology, you start with the design. So, scenario-based design is particularly devised to get you away from any kind of technology because that can come later. Now, as you already know, you have two kinds of measures, quantification and qualification, okay? Quantities and qualities. They are not discrete categories, okay? They are in fact a scale. So you can have something that is very qualitative and something which is very quantitative and a variety of things in between. So this is often quantitative data, things like often referred to as hard data, objective measurements, and RTs stands for reaction times. It's probably the most classic example of a hard measure here, okay? And then you got soft data, and that's descriptions, impressions, subjective, and so on. Now, sometimes you may realize the way people talk is that, oh, we've got hard data, therefore it's better than soft data. Not true, okay? So you should avoid terms like that, because what really happens in real life is that you use both types of measures in the same study, and you often, the same measure goes from one to the other. In other words, you can actually take hard data and deal with it in a qualitative way through description and vice versa. So you go up and down the scale. So you don't actually say, which should I use? You say, what does it take to actually obtain reliable data? Okay? And in real life, it's a mixture of approaches. So in the same study, you might be using both qualitative and quantitative, and in some of those instances, qualitative might be converted to quantitative, and so on. It can be hard, if you're not experienced, to make the decision as to what kind of measures to use, but there's nothing new under the sun. So basically what you do is that you will look at previously published papers that are actually doing similar work. Now, it doesn't matter whether that's academic or in industry, they are doing similar kinds of work, and you just go with what it is that they are actually doing. And if you invent your own measures, that's normally not a good thing to do, because you cannot actually answer questions about how good your measures are. So if there is things that have been published, such as reaction times may have their limitations, but they have been described mathematically and empirically for well over 150 years, okay? So there's very little about human reaction times that's not known. Therefore, it's quite safe to use them, because if you see some strange things, you can actually account for it, okay? So inventing new measures, not a smart idea, okay? Go with what others have published, because what's been published has actually been peer group reviewed and people have deemed it to be good, okay? In the real world, we have pragmatics, and those pragmatics tell you that qualitative data is usually also quantified. So the most basic kind of measurement is to count, okay? One of these, two of these, three of these, and so on, okay? And counting is very basic and also very, very reliable, because what it gives you is percentages, which are easy to communicate, and it gives you frequency or nature, which is very often qualitative. Your kind of evaluation do it against. So in a way, the nominal scale is, as the name implies, the clue, by the way, lies entirely in the name. Nominal means it's a name only, okay? So, and there's no relationship between the different names and other categories. I'll show you an example in a moment, okay? Then you've got an ordinal scale, which is the order of things. Something is ahead of something else or behind something else and so on. But it doesn't tell you anything about how much. Whereas an interval scale, they have more meaning in terms of the amount of difference that is there. And then you have the ratio scale, which is a continuous scale, okay, and that is like reaction times, and they are the be-all and end-all of measurement, okay, and it has thought to their scalings.
Надо кое-что попробовать. Ага. Так. Так, на этот я могу ответить. На это смогу ответить, но как-то слишком много пунктов за это надо попробовать. Это будет. Здесь что? Я не понимаю. Надо будет пересмотреть, перечитать.
and are wanting to do statistics on nominal scales, which cannot be done. It's meaningless. Some idiots do and mislead themselves. And not only am I referring to idiots who are students and get told off for that, low marks or something for that, but I'm talking about industry seriously misleading themselves and embarrassing themselves. This is so wide now that the government has brought in the National Institute for Statistics as a separate entity where every government, or you could be in none, or you could be in one, you could be in two, okay? But the relationship between them is non-existent, okay? So you just simply are counting things. Some errors, for example, are counted this way, so you've got mistakes and slips, okay? Sort of something a bit more meaty, or just also that 7 is never, but you can actually indicate, and they users, they can be added. The scale is per category, and then you describe them. So report on a ratio scale, and they can be very information rich. Now, there are interval scales, metrics. However, you can cheat. No, sorry, you can actually do some clever stuff. If you have a proportion of something, then proportions are always normally distributed on a ratio scale. Okay? So if you have a number of errors, you have, let's say, 500 errors in your total experiment. It can, okay, been here before, minus is, or this, and so on. And what descriptive statistics do is to provide a numerical summary of a data set. Okay? That's any kind of given data. Okay? And you've got to be aware of the fact that what you're really doing is that you always have a sample. You don't have an entire population of users. You have a bunch of users you have somehow recruited or chosen, or a lot of decisions you've obtained. Okay? Together, we have something which is called measure of location. Okay? That's the statistical term for describing a summary. You will recognize the sum of the set of scores. If you do a dot plot, as it's called, this is basically a frequency count. You can do that into each of the numbers. That may not seem to repeat a average for the two, and they are pretty closely the same, are they not? 7 versus 7 point. Go back to this, okay? So they both actually have the same, I think it's coleslaw sales, and in thousands of pounds. And we're now looking at, for example, the median. And if we put the coleslaw den into an order, the middle, okay? That's just in pounds. So the right time and the number of, describe the data, okay? 0 is the best description. In the same way that the median for the other data is what you really wanted to, it's usually normal. And that's the mirror image, and so median, okay? So what happens here is, we're not going to be describing it, okay? But if it's not, it's of variance. So a low procedure level deviation.
Это математика неинтересная. Это понятно.
Which is, well, we have augmented reality, which is using not back to immediately the notion of a mental model is together then they understand what happens. In other words, it's what you do. How do you do that? You do it through the metaphor, okay? The idea, stop metaphor. And that's it, okay? Have this event-driven command structures, okay? You could do everything that you do in clickies with of affordance, okay? And I'll explain to us. No, you must admit it's visually quite simple, easy to read, nothing very complex about this. But does it tell you what to do? Which is the definition of an affordance. Use your EasyChair account to sign in. An account seriously wrong with you not to get these. Okay, these are real instructions. So that would count as high affordances. I don't know. Also tells you what to do. Word not this or this. The things can be also quite in actual place, which was content addressable filing, CAF systems, was a vast library metaphor. Okay, the sort of the great library of Alexandria. Okay, metaphor. And ENIAC to do computers as do on occasion for a little demonstration. Okay. The voicemail, for example, has as an answering machine or mailbox, that has been a success, and so on. Expecting actors to be something government. The GUI, okay, something that represents something else. That's the most simple definition of it, okay? And it was 1970, Alan Kay in Xerox Park, California, who came up with icons that represent a file. Icon links to my file. This icon is my file, okay? So you've got representations, links, and identifiers. Notice how much this is like a conceptual model, okay? You've got objected in the and Smalltalk 90 in 84, obvious because it had been studied for a long time, is that human recognition is much superior to read items, making cognitive in a movement of some instrument. Okay, this is pretty extreme, but you can see how if you are designing something which has strong physical metaphors, you can use this approach to make a bridge to the users. All day, pottery embellished with imitation rivets, reminiscent of similar virtual reality things. In this day and age, usually immersive, well, these all very, very powerful. And there are all kinds of interesting doing on a piece paper to cursive interface using OCR hugely. Okay. Now Amazon is selling 2 terabyte USB sticks. Yeah. Okay, they're a bit expensive, but yeah. And so what are the consequences? It's great. I don't run out of anything, but I can also not find anything. So at the moment, where to find files in a system, but the actual menu system in, let's say, Windows is designed in this manner, and it maps well, like hierarchical task analysis, which you've done, to the way that our brain think or what to work on. Okay, so this is an user interface design task where the links need to be meaningful. But this is like a conceptual model, okay, and this is very nodes have attributes programming, okay? And you can see the similarity. The links here are logic links, okay. Saturn is a court owns, okay. These are actually prologue links, and you've got nodes, you've got categories. Category is mammal, animal, bird, okay, and then you've got various. Would be, we're talking about future desktops, and we're talking about being able to structure a user interface based upon your associative memory model, your ontologies in your own head. Okay? This is a picture which shows you the web, and it shows you where things are actually going. The old PC era, Web 1, 2, 3, and then how these structures are being developed in and cognitive science. How the way you work, you are trying to multiple metaphors in your home. We break.
Так, это понятно.
Okay.
Так что вот это вот прошел. Да. Тут больше воды.
We're going to do a mishmash of things today, as we will do next week, which includes several exam briefings. Yes. The time of reckoning is coming upon us. Okay? So, firstly, I want to actually add to some previous stuff I've spoken of about expert evaluations. I'll then speak a bit about the exam. We then break, and then I have some practical work lined up for you, which I'll explain later. Okay? Hopefully this will all make sense. Now, when it comes to the type of evaluations you do, remember that we're talking about things like formative and summative evaluations. We're talking about the process that actually occurs during the development of a system. That's the formative, which takes multiple methods. Some of you have done qualitative evaluation methods. They are involved. You should have some idea now about quantitative methods. They are also involved, at least at the level of scaling, such as Likert scales and so on. And then there are two other methods which are actually sort of, you could say, slightly different. One is automated, and most of you have actually been exposed to Cogtool, okay, through Jean-Claude's class. Cogtool is absolutely classic example of automated evaluation. It allows you to model the users using your particular interface at the time that you're developing the system, and gives you very useful data. In other words, there are no users involved in that. Okay, it's modeling, and its use is increasing because understanding increases, but also at the same time it does address a number of issues to do with having access to users, which can sometimes be a problem. The other exception is expert evaluation. Now, don't confuse expert evaluation with just, he or she is an evaluator and they're pretty expert, okay? This is actually a term. So, if I may remind you that what we have is, for example, usability testing of various kinds on the right-hand side here, which is usually in the field or in the lab, okay? It usually is pretty rigorous. It involves experimental designs. You've actually done an exercise on factorial design and how to design studies, and you do seem to understand that pretty well. Now, field studies are more or less the same. They're the same in terms of what you do. They're slightly different at times in how you do it. So in the lab, you've got a much more controlled environment, whereas in the field, you haven't. And field here refers to just non-lab. Obviously, you're familiar with the idea that a field study is in the user's own working environment, office space, call center, hospital ward, wherever the uses actually normally work. Okay? Now, there's this whole category of inspection methods. And inspection methods are, for example, things like heuristic evaluation, which is mostly associated with Jakob Nielsen, and which I have mentioned, shown you, and have slagged off, because these heuristics, useful in their own right as ideas, they actually, in being used by someone who doesn't know what they're doing, will not give you very good results. They are a problem in the whole industry, because companies tend to think, oh, we need something done, we don't have much expertise, let's just use a bunch of heuristics. They get results which appear to be okay, but they have no idea whether they are reliable or not. Okay, simple as that. And so there is a lot of worries about them. Whereas in truth, a heuristic and to use them is actually not a bad idea at all if it's done by someone who knows what they're doing. So you can get, I mean, I want to focus on to today, okay? So, like I was saying, you again, this is, I briefly introduced you to this, which is that you've got structured and cognitive walkthroughs. These terms are confused all the time. Structured walkthrough just means being systematic, okay? And walkthrough simply refers to looking at something step by step, okay? And for example, it is really useful for looking at how well a design supports users in learning the tasks, okay? Learning how to do something that's going to be done in the interface. It is extremely, you realize who have programmer of time also actually think about each of the steps that is of an expert panel can to actually what are the clouds and you know, a scenario cognitive science are very, Jakob Nielsen's 10 heuristics have been slagged off heavily. Not the heuristics themselves, but the way he actually says that anybody can use them and just do a quick something here and it'll all work. That's been slagged off. There is a whole area of heuristic evaluation which is actually quite thriving. What are initially the 10 heuristics that that Jakob Nielsen put forward, they all make sense, but it's their definition and how you understand them that is a problem. An expert could take these and actually define them for themselves in sufficient detail that they are quantified, okay? Whereas if you gave this to a whole bunch of people in a company, they would all come up with very different results, because most often it's a single UX expert, and the reason is quite simply that it's the cost and finding the right kind of experts, okay? Then what you might find is that the expert goes through a heuristic evaluation of the site using Nielsen's principles in mind. You know, that these are sort of 10 major categories, but they would actually define it in much more detail. So those of you that have done the qualitative course will actually know that it becomes a sort of qualitative measurement or recording issue, that the expert is doing it in their own time. They can actually use the heuristics as a guideline and then in minute detail start to record the impressions of, for example, system status, system visibility, and so on, and they make extensive notes on it, okay? What an expert would then be likely to do is to obtain user scenarios from the designers and use that easily site logs, which is basically you take the logs and you look at users, because you there has collected any data. In many cases they have collected, you know, either formally or informally, but you want to access it and you want to work with it. About 2 years. Accessibility, in other words, websites are more and more global, so you've got to be a bit careful that if you are crossing cultures, that not just that you're giving offense in another culture, but for example, there's some very interesting work being done on color schemes. And for example, Western colors do not correspond at all to Asian colors, meaning happy, good, bad news, and so on. It's completely different, okay? So you can actually go and not necessarily cause great offense, but not do yourself any favors. So how can you avoid that? How about hiring some local experts? Okay, it's very simple. So if you want a version of your site in China, get some Chinese HCI people involved and let them actually loose on making sure that you're not doing anything that is overtly stupid. Okay. This is the sort of bare minimum that you would actually want to look at when it comes to accessibility guidelines. Okay? You want alternative text descriptions for the images. You want alternative text descriptions for the navigation links. Okay? You want all functionality accessible from a keyboard. Okay? You want readable text as defined by the accessibility board. Okay, which is adequate contrast between text and background, font selection, etc. You want the ability to customize the font sizes, and you should be altering in this day and age alternative dyslexia-friendly fonts, okay, which are now identified, and it might not be the perfect, but it is better than many, okay. Audio materials should have text alternatives to for example, videos. Okay, you should have adaptable presentation. They were volunteers. Okay, contains flashing images.
Так, это простое. Теперь это надо посмотреть.
While I still remember, this module 4110 was rebadged this year. So if you want to see the older exams, they come under CM 408, which is the old module number. Okay? So you'll find there are no old exams for 4110. So I think they call it in the business community rebranding. Why, I do not know. But then I only work here. Okay. So if you've downloaded this, these slides are on Moodle. It says, I realized on the slide that it's a 2-hour exam. It's actually a 3-hour exam. I'll correct that in the next hour or so. They're always 3 hours, okay? And it's the same old game. You'll find something from all aspects. It is officially a closed book exam. Typically a section on you know, it's the same old game. There's nothing special about this exam at all. However, I use a style of questions which I mentioned last week, which is known as headroom, okay? It's the headroom approach. And so the majority of questions you'll see on the old exam take the following structure. There's a stem, okay? And the stem is some form of introduction to the nature and the content of the question. Okay, I'll show you examples of that in a moment. Okay, very straightforward. I often refer to it as the contextual bullshit that sets the scene. Then you've got typically a section on bookwork, followed by another section on bookwork, and they typically count for something like 5 marks each. Okay? Okay, so that's just straightforward. Again, I'll give you an example in a moment. And then it's followed by the final part, part C, which is the problem-solving synthesis, and that's referred to in the education trade as the headroom part. Because what that does is that it allows you to actually go beyond just simply answering a question. Okay? So typically a question might have bookwork A, 5 marks, bookwork B, 5 marks, and then problem-solving synthesis, 15 marks. Okay? I have also been known to cheat, and if people produce some really good headroom answers, I will steal marks from other bits to put in there. Okay? But that also allows you to be creative and to be open. Okay? So, there are slight exceptions to this. There are occasionally questions which are quite a long ones, A, B, C, D, E kind of thing. But, you know, you'll see all these examples on the, in the old exam papers. Here is a neutral, typical example. So the stem here goes like this. Cooking is an increasingly popular recreational activity amongst middle-class men. Okay? A, what is meant by the term recipe? That's bookwork for 5 marks. Okay? And then B, what important role does water play in boiling eggs? Again, bookwork, okay, 5 marks. And then comes the headroom. The School of Computing asks you to cater for their Christmas lunch. Design a 4-course meal, justify your answer, and give examples of problems that you might experience. Approximate costs should be included. Okay? Now this would be for, let's say, 15 marks, and in this case there is no correct answer. Okay? So it depends on how well you design the 4-course meal. Okay? This allows you to be creative. This allows you to do something slightly different. Okay? It allows you to show that you have understood what problems you might encounter in cooking things, such as timing and getting all the timings right, and etc., etc. Okay, and it shows you that you can cost things out. So this actually is the kind of synthesis, and it's an unseen problem. Now, here is an example that does fit into the course, something along the lines of Company X has a website with the following characteristics. Okay, now those formative characteristics can be that it's aimed at students, okay, that it's a university site, that it sends out newsletters, that there are reports to be downloaded, yada yada, you know, that kind of thing. Then come the 2 bookworks. What is formative evaluation? Okay? So that's easy enough to define. Okay, set of methods used during the design process to guide the design, and so on. Okay, e.g. cognitive walkthrough, expert evaluation, etc. That will give you 5 marks. And then B, why are heuristics such crap? And that's because they are not defined, okay, and they're hard to use because they're not defined, and you don't get iterator reliability, and people like Rossen and Carroll think that they contribute absolutely nothing. And that's in the lecture notes, actually. So it's bookwork. Then comes the real sort of headroom part, which is design an evaluation study that answers the following question. Okay? And then you might be, you know, then you would actually get the question. The question would be something like, how easy is it to currently find course information on digital media design? Okay? Something straightforward like that. And so you're being asked to actually set up a little study, and then you're being given some guidance, which is you must say how you might set usability criteria, how you might get the users, how you might measure things, how you might summarize data, etc., etc. So you're not left totally on your own. The questions specify the kinds of things that you actually need to be doing. And you will find that this style of question occurs in every exam. Okay? Okay? The practice you are advised to have a look at, and these would be, for example, you don't get any prizes for knowing that you need to know about scenario-based design. Okay, what is it, and how does it contribute to user-centered design? In other words, it's a communications mechanism which value adds, doesn't replace, but value adds all user-centered design methods, okay, through allowing greater communication between the designers, between designers and users, between users and users, blah, 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 between everybody, okay? And it allows you to reason and think about issues, and a lot of different issues. You need to understand also the stages of scenario-based design. So you have a requirement stage, you have to collect the right type of information, okay, you have activity designs, okay, and you have information design, and you have prototyping and so on, okay? You need to know how to write a scenario, and you've all done that now, and there are quite a few examples on the Moodle site, for example, from the whole website from Hawaii, where they did a major postgraduate SBD exercise, and all their results are examples are there, and so you actually have got good examples. But you must be aware that when you do a scenario, problem scenario does not mean a problem in the negative sense, okay? A problem just means that it's in the problem domain that is being looked at. So any scenario can be problematic or non-problematic into an annotation. If it doesn't actually work, well, you need to change your scenario. And of course, you need to do some claims, and the examples I've seen from your courseworks, for example, would indicate to me that you are actually not just able to do it, you're doing it extremely well. And of course, you need to know about storyboards. Storyboards, you'll realize, feature very largely in scenario-based design. They are an important way of expressing, based upon my own experience in research and practical work, they are an extremely powerful way of thinking, and not a million miles away, okay, is the role of task analysis. Task analysis is how you actually start to convert what it is that you need to know about users into a design. And that's the sort of general role. I don't expect you to read widely around the topic of task analysis. I mean, it is an extremely wide area, but I think that as you have heard in the lectures and as you have done in practicals, you need to be able to take relatively simple scenarios and turn them into a hierarchical task diagram through having a set of plans and producing the diagram itself. Those of you that chose to do that and sent to me in the practical did a very good job of it. So some expressions of it were quite creative, but you know, everybody seems to understand what is needed to do a task analysis and to produce a good set of plans and diagrams. What people often do wrong is that they actually seem to think that the diagram matters most, whereas the plan is absolutely crucial. But you have the steps that are needed listed before the actual diagram is all the course. And basically, you see it in things like the conceptual designs. They are about designing things like using mind maps and mind map type structures, in other words, non-linear linking. This is how the World Wide Web works. This is human associative memory, which that link has been made. Okay, as humans, we are mostly linear because we can only speak one word at a time. And we are only linear in our writing because, and practice, for instance, to mental models. Interestingly, what the students do is to produce something which is sort of resembles Microsoft Word in some ways, which are carried out during the design process to guide the design, and summative, which tend to be very quantitative through a variety of evaluation, okay? And that is, you need to know the difference between formative and summative evaluation. Formative being done through a variety of methods which are carried out during the design process to guide the design, and summative, which tend to be very quantitative and are done at the end or at a certain stages, but to give a kind of definitive, is it usable, is it not usable, does it have high UX or low UX, and so on. Okay? And you need to be aware of the fact that you'll be asked to design some studies for a particular purpose. So, you know, how might you find out about the users here? How might you find out whether it's easy to get at this information or something like that? And all the practical work that you've done and your assignments more than adequately prepare you to answer those. Typically, you need to give a little focus on things like cognitive walkthroughs. This is, for example, used when you are dealing with hierarchical task analysis networks and you walk the user through the diagram, testing out, in each case, how logical the structures are. Cognitive walkthroughs are also used to talk users through the problem scenarios. You know, now, why not just call it consulting the user? Because it is much more systematic. Okay, you have a set of stages and phases that you want to go through with the user, one after the other, to obtain information, and you would have multiple users involved. When it comes to evaluation, you cannot get away from heuristics. There are Jakob Nielsen's heuristics, which the way he promotes them has been shown to be pretty inadequate. But if you are actually going to judge anything, then heuristics are good. And probably, though, the best way to use heuristics is through expert user evaluations. And we recently covered how that's actually carried out. And there's quite a difference between willy-nilly throwing heuristics at users and saying, you know, in a company, let's say, every member of staff, you take these heuristics and use them, and an expert who has already defined the heuristics in detail, okay, and knows exactly what they're doing and provides quantities for them. Because after all, a heuristic is just a rule of thumb that allows you to do something systematically. Expert users, okay, is something which you'll find that if you come anywhere within, in the future, in your jobs come anywhere near HCI or UX work, you will be expected to act as an expert user evaluator. Okay. Last week we covered accessibility, which in this day and age you always have to cover anyway, and it's an issue which is growing all the time because the expectation that systems are accessible to all kinds of different social groups, okay, and user characteristics, not just the sort of obviously disabled but socially disadvantaged and so on, this awareness is growing. And I gave you a set of guidelines, and you can actually separate those into what we could say is ideal. The ideal is that all things are accessible to all people at all times, but that's not always possible. So we have a sort of minimum guidelines from WC3, which you've got a copy of now, and then you need to know how these are best applied in your own kind of domains, if you like, and that's usually best done by expert user evaluations. There's a lot of accessibility work done by automation, and you can do that for free. You know, there are websites which assess other websites and tell you how well you are conforming to W3C guidelines, but mostly you need to build up your own expertise in accessibility and use that yourself as an expert to carry out an assessment of some kind, or you actually get people like Mike Heron, for example, who is an expert on it, to come and do it for you. Obviously, you've got to be able to understand the difference between usability and UX. Okay, usability being largely functional and UX being wider and taking into account the experience of users, the more emotional, softer side of the user's experience. Okay, you've done some use the semantic differential, and so I think you have a fairly good idea as to what the issues are. This is one of those issues where you cannot have a definitive definition, but quite clearly, while UX and usability usually go together, they can exist fairly independently of each other, okay, in certain cases, either by accident or deliberately, okay, and in some ways, usability, you could say, is a subcategory of UX. In other words, UX is a wider measure or assessment of how the users have reacted to a system, usability referring more to whether it actually works or not. And in that context, you've both done exercises and you need to be well versed in how to set usability criteria for any given site. Again, this is not a hard and fast correct answer. It has to be reasonable, okay? So this is when you actually have to define them, you have to set them, and you have to specify how you might measure things and how data might be collected. So for example, if you're lucky enough to have a problem which says how easy is it or how fast is it to can users access information on a site, well, the word fast gives it away totally, and you would actually define your usability criteria as speed and measure it through reaction times, and Bob's your uncle, life is easy, okay? But sadly, it's usually slightly more complicated, okay? So you're talking about usually ideas such as ease of use, okay? And an ease of use can be speed, but also errors and perception. So in those cases, usability criteria would also cover UX criteria. So in those cases, you would have sort of usability measures, speed, errors, and so on, and more qualitative measures, which allow you to say how did the users perceive that things are going and how they have done on given tasks. You realize that there are occasions when you do something to, let's say, a website, and the usability measures do not change, but the UX changes. In other words, your changes are not giving any faster performances or any more accurate performances, but the users are happier, in which case you tend to just go with that. Okay? And when we come closer to the 15th, I'm happy to arrange another revision session if people so wish. But I ask only one thing. You need to ask for it. Remind me, in other words. So if you're coming up to halfway through May, into May with the exams, if somebody reminds me that there is people want this, then I can arrange a room and a time, and I can come and answer questions. Go on. Are you asking me whether I'll mark past papers? Yeah, well, okay. As long as it doesn't become, I mean, I can't be, but yeah, I will actually. If you do send practice questions through, I will provide comments on them. Yeah, I'll do that. And I'm also happy to answer questions via email, and I usually separate what I call specific issues versus general issues. So if somebody doesn't understand something and it seems to be specific to that person, I'll obviously just answer that person. But if it is something which I think there's a lack of clarity, then I will actually also reply to the whole class. And I don't name the person, you know what I mean, but just sort of spread the answer around, because I think that something is cropping up. So if I'm being asked a question by several people, I normally tend to think that's clearly not clear enough. So otherwise, don't be shy, because you know, and it's not in any way daunting. People do extremely well in this exam, and I'm expecting you to do the same. So